Normal distribution. Okay, here we go. When we have a normal distribution, there's usually going to be certain percentages in between each standard deviation. So remember, this is one standard deviation. This would be two standard deviations. Now, there's different types. This is a normal, and we're going to focus on normal. But if you had something like this, where most of the data is at the top end, it would be positively skewed. That's crooked. Sorry about that. Again, this would be normal distribution. And if most of the data is on the bottom end, then it would be negatively skewed. Now, we'll get back into this. However, if I were to give you a graph like so, like this, you would look at the percentages over on the left-hand side. So each of these bar graphs represents some sort of percent over here. Now, I personally like to write in my estimated percentages for all of these first. So that's about what I'm guessing. So about 42 here, about 24 here, 24, 5, and 5. This first question, it tells us that the mean is 115. So again, in a normal distribution graph, the mean is typically right here at the top of the point. Approximately what percent of female brown bears weigh between 100 and 129? So here's 100, here's 129. So these three sections would be what I'm looking at. So I'm looking at 24 plus 42 plus 24, which would be 24 times 2 plus 42, 90%. So about 90%. Now, if you flip over the question, I'm still going to be focusing on this. The next question says, approximately what percent of female brown bears weigh less than 120? Back. So here's 120. So less than 120. So I'm not including this. I'm looking right here. So I have 42 plus 24 plus 5. 42 plus 24 plus 5, which would be 71%. Now this one said the standard deviation is 10. Remember, they already told us what the mean was at the very beginning, was 115. Approximately what percent of female brown bears are within two standard deviations? So again, if I move one standard deviation, this would be 125. If I move another standard deviation, this would be 135, because it gives us our standard deviation right here. If I subtract, that'd be 105 and 95. So between 95 and 135. So if I look at this, 95 is in the middle here. So this would be like half the data. And 135 is in between here. So it's asking what percentage of the data is in between these two spots. So this would be half, so about 2.5. This is half, about 2.5. You could add these all up. So 2.5, 24, 42, 40, or 24, 2.5, or this should all total 100%. So I could do 100% minus 2.5, minus 2.5. Either way, you would get 95%. And that's why math is so grand, because either way you do it, you would still get 95%. Okay, problem number 2. Remember that curve that we had at the very beginning. We're going to sketch a normal distribution curve. So now in a normal distribution curve, we have a curve. So you should draw something like this. You have your mean always goes right down smack in the middle. And then you should draw 3 on each side. Dot marks. Now, in between, this is going to be the standard for any normal distribution curve that you're going to draw. In between one standard deviation, so with them moving one, each of these little sections have 34% of the data. Now, each one of these little sections have 13.5. So again, these percentages that I'm writing in here do not change. These each have 2.35. And then your tail each has a 0.15. So this is half your data. So these numbers should all total to be 50%, because the mean is right smack in the middle. And they do. You just got to trust me if you don't believe me. And how do I fill in my numbers here? So this is going to be the same for every single graph that have a normal distribution curve, but what changes are these numbers down below. So the mean always goes right here in the middle, 21.1. And on the right-hand side, you're going to add a standard deviation each time. So if I do 21.1 plus 4.7, 21.1 plus 4.7, I get 25.8. Now I'm going to add again the 4.7. So each time you're adding a standard deviation. go to. Sorry. This is where 35.2. So on the other hand, you're going to be subtracting. So 21.1 minus 4.7 will give you 16.4. Subtract 4.7 from this, I get 11.7. Subtract 4.7 from this, I get 7. Now this is questions just asking you to draw the curve. Typically, there will be questions based on these numbers that you find, like this one down here. So this problem number 3, the first thing I want you to do is try to draw a curve just like this and label your numbers down below. So I'm going to pause and then show you the answer. So I want you to try to do it yourself first. So your curve should look at something like this. So now again, based on the curve that you draw and the numbers that you find, typically there will be questions. It's saying, what percent American males are in between 67 and 74.5? Now, if these numbers don't show up here, you probably have wrong numbers here. These numbers that are being asked should correlate here. So in between 67, so right here, until 74.5 right here. So it's asking for the percent of people. So each one of these sections give you your percentage. So that's going to include my 34 plus 34 plus 13.5. And I would get 81.5%. Now this next question is the same graph, except it's on the next paper, which doesn't really help you. But saying, about how many would you expect to be 72 inches or taller? So if I go back here, here's my 72 right there, saying 72 or taller. So this is where you have to remember this tail is 0.15. So if I add those all up, bing, bada, boom, I'll get 16%. 16%. So I want you to try to do this next one by yourself. So your curve should look something like this. Now this first question says above 180. So that's going to include your 2.35 section and your tail, which is 0.15, 2.5. This one says about how many score above 135. So above the 135. Now I personally, this section right here is 34%. Again, I didn't write it in, but we know that from the beginning. Remember, this is 50% of the data right here. Above the mean, below the mean is 50% of the data. So I chose to do 34, this section, plus 50 to get 84%. And there you go. Bing, bada, boom. Amazing students. You got it in the bag. Have a great day.